Okay, so my talk is about multi-view dynamic texture learning. We know that we see a lot of static texture in the real world. And if we have a temporal domain, and so like the waves and like the trees, then we will have what's called a dynamic texture. Okay, so that means we usually see in a lot of videos. And to solve the dynamic text problem is a very challenging problem. So like for example, in this case, we could have applications such as traffic monitoring, video surveillance, of course video retrieval, and many other applications. And one way to solve some of this problem, for example, is to, don't know why the video is not showing, is to track, like for example, in this case, we want to count the crowd. So one way to solve this problem is to track everybody that is moving. And another way, which is introduced in this paper here, is through dynamic texture analysis and segmentation. So what we do is we introduce a model for multi-view dynamic texture learning. And the idea basically comes from we know that if we try to solve a problem, usually there is not just one single optimal solution. So therefore, we consider unsupervised clustering problems for multi-view domains. And also the disagreement between the class labels suggests that different views can be computed even when using unlabeled data. So for example, in this case, for each video break, so that is the spatial domain and the time domain, the temporal domain, and we basically use 6 planes. Okay, so here we show the 6 planes for each video break, and with each plane we compute 2 features like the web local descriptor and the local binary patterns. Then we use this probabilistic random index basically to compute, through computing this PR index, we found out and which one is more reliable, and then we combine this by, or estimate the hidden ground truth by solving this optimization problem as expressed in this mathematical equation here. And in the experiments we conducted, we compared a number of state-false approaches, and for example the generalized principal component analysis approach, the dynamic texture model, all these have been given in the references. And so we presented both the quantitative comparison results and also the qualitative results as well. So for example, for this data set, we have roughly 300 videos, and the first 100 basically we have is a 2 label problems, and the second 200 is a 3 label problem, and the last 100 is 4 label problems. So we computed the quantitative number, the PR index, and with all the methods in the literature, and also our method. So as you can see, for each of these video clusters, our method has performed better. And we could also look at this, of course, qualitatively, and so by looking at each frame of the image in the video. And so again, we show that our method are able to do motion segmentation even with very challenging motion areas. Okay, so to conclude, we have presented a model that can automatically segment time-varying characteristics and phenomena. So the new features are derived and used in our description of dynamic texture, and then the new method is introduced to simultaneously combine several views to achieve a more reliable result and to incorporate the local spatial constraints between neighboring observations. So the key for the learning is one is probabilistic random index, and another one is the EM algorithm, which are the core which we use for the learning solutions. So if you are interested in this paper, you can come to talk to me more in the poster. Thank you.